Next we discuss about another problem. This problem is so simple. Let D be the Euclidean metric on R square. The Euclidean metric on R square. Define delta pq equal to dp0 plus dq0 where p not equal to q and 0 if p equal to q. For pq belongs to R square, then delta be a metric on R square. Then we have to show that delta be a metric on R square. Okay, and delta p epsilon. What are the delta p epsilon for small epsilon greater than 0 and p not equal to 0? Okay, now we start about these things. This one equal to obviously del pq greater than equal to 0, and del pq equal to 0 implies by p equal to q, and del pq equal to del qp. Okay, now discuss about del pq less than equal to is equal to dp0 plus dq0 when p not equal to q, less than equal to dp0 plus dr0 plus dr0 plus dq0. Okay, where dr0 greater than equal to 0, this equal to dpr plus dq or rq. Okay, then sorry, not d, delta. Okay, then dpq less than equal to del pr plus del pq less than equal to del rq for p not equal to q not equal to r. Obviously, then triangle inequality hold, then delta be a metric on R square. Okay, then delta be a metric on R square. Now we discuss about these things. Be delta p epsilon. Okay, what are the b delta p epsilon? For sufficiently large, for sufficiently small epsilon greater than 0 and p not equal to 0. If p not equal to 0, and 0 less than r less than dp0, then p delta pr equal to singleton p, and for p equal to 0, b delta pr equal to bd0r. Okay, then for p equal to 0, B delta epsilon B delta P are equal to B delta P are equal to this one BT 0R. Okay, that means we see about that B delta PR equal to singleton P when 0 less than or less than equal to dp0. And next we see that for p equal to 0, B delta P are equal to BD0R. Okay, then we erase all these portions. Okay, and further proceed another definition. Equivalent matrices. Definition of equivalent matrices. Okay, start about that. Equivalent matrices. Two matrices G and D dashed on a set X. Two matrices G and D dashed on a set X are equivalent if the topology is generated by D and D dashed are the same. This is equivalent to say that U subset of X, that is U subset of X is D open if and only if U is D dash open. Okay, that means that this one is the definition, that two matrices D and D dash on a set are equivalent if the topology generated by D and D dash are same, that is U subset of X is D open if it is D dash open. Okay, then we proceed further topics. Also. Next we discuss about further topics. Then we start these questions. We start from some questions. These questions are so simple. Two matrices D and D dash on X are equivalent. D and D dash on x are equivalent if and only if given any x belongs to x, any open ball BDX are contains a open ball B dash D dash contains an open ball BD dash contains an open ball B dash D dash X row for some row greater than 0, and any ball and also any open ball and also any open ball BD dash XS contains in BD dash XS contains BDX sigma for some sigma greater than 0. Okay, then two matrices D and D dash are equivalent if any open ball BDX are contain an open ball, this one. Okay, that means that BD dash X row subset of BDX are for row are greater than 0, and also any open ball BDX subset of BD dash XS for is sigma greater than 0. Okay, then we erase all portions. Obviously we know about that equivalent matrices. Then we further proceed this problem. Okay, how we handle this problem? We handle with this problem, let y belongs to BD dash X row for row greater than 0. Okay, then this implies that D dash XY less than row. Okay, this implies that D of XY less than R for some R greater than 0. This implies that Y belongs to BDXR. So BD dash X row subset of BDXR for row and R greater than 0. Okay, let Z belongs to BD X delta. Okay, for sigma greater than 0. This implies that d of xz less than sigma. This implies that d dashed xz less than is for some is greater than 0. This implies that z belongs to b d dashed x is. So bd x sigma subset of bd dashed x is for sigma and a is greater than 0. Hence we see about that d and d dash are equivalent if and only if given x belongs to x, the bd dash if and only if x belongs to x, bd dash x row subset of bd xr and bd x sigma subset of bd dash x is. Okay, for some r and a is greater than 0. For some r is greater than 0. This also. Next thing, we also discuss about some questions. The matrices T1 and T infinity are not equivalent. Okay. And now we erase this portion and we discuss about these things. The matrices D1 and D infinity on C01 are not equivalent. That means T1, we know about that T1 and D infinity. The open ball here the open ball all B infinity 01. First B1 01 equal to those if contained in C01 such that norm of f less than 1. Okay, in C01 norm 1, in C01 norm 1, and also this one is, and the open ball the infinity 01 equal to those f belongs to C01 such that f infinity less than 1. If infinity less than 1. Okay. In C01 norm infinity. In C01 norm infinity. Obviously, then this one is not open. This one is open in C01 infinity. This one is open in C01 norm infinity, and this one is not. This one is open, and this one is not open in C01 norm 1. Okay, then we call about these two norms are not equivalent. These two norms are not equivalent. Norm 1 and norm infinity are not equivalent. And now also then we call then norm 1 and norm infinity are not equivalent. So d1, if we generate d1 xy equal to summation k equal to 1 to n, not in C01, in C01 d1 is d1 fg is the difference of fg, I think. Okay, norm infinity equal to supremum of fg, supremum of fg and continuous functions, that means difference of fg. Okay, norm 1 equal to norm f1 equal to 0 to 1 ft mod of ft dt, and norm infinity f equal to supremum of ft t belongs to 0 1. Okay, where this one and then these two are d1 fg equal to integration mod of fg pt dt 0 to 1, and d infinity fg equal to supremum of fg t dt t belongs to 0 1. Okay, then d1 generated by norm 1, d1 generates norm 1, and d infinity generates norm infinity. And so d1 and d infinity are not equivalent. Okay, then this one is stop here, today stop here.